In this example, we'll use the assembly file assembly chassis front ds from the front loader design to demonstrate the workflow for dynamic simulation to stress analysis. We'll start off by making sure that the level of detail is set to dynamic simulation by right-clicking it in the browser and then selecting Activate. We'll then switch to the Environments tab and select Dynamic Simulation. The dynamic simulation environment is a rigid body dynamics environment that allows you to simulate the motion of an assembly and extract from that analysis the forces, reaction forces, and loads that the parts in the assembly will see under normal operating conditions. Once in the dynamic simulation environment, we can collapse the grounded entry in the browser, and then in the graphics window, we'll select on the cylinder assembly, which will then highlight the applied standard joints of revolution and cylindrical in the browser. Let's right-click on the cylindrical joint and select Properties. In the Properties dialog box, we'll select the DOFT tab to display the initial conditions for the translational degree of freedom. We're going to edit the initial load condition of the position by changing the value to 200. And then selecting OK. Next, we'll apply a couple of load forces to the bucket by selecting Force from the Load panel. Then, select a point at the bottom of the bucket, and then select the edge to specify the direction of the load, and be sure to flip the direction to point down. Switch to the associative load direction and enter a value of 1,250 newtons for the magnitude, and then select Apply. We'll repeat this operation for a point on the mirror opposite side of the bucket and enter in the same values as we did for the first set. We can select OK, and once done, these forces will appear under the external loads in the browser. What is not known is the kind of force that the cylinder is going to have to apply in order to lift the bucket, so we'll use the unknown force from the results panel to apply a force required at this joint to maintain static equilibrium in the assembly once the load and motion is applied to the bucket. We'll deselect Display, and then click OK. The output grapher will open to animate the dynamic simulation. If the dialog box is in the way, you may want to move it and/or make it smaller to see the simulation on the graphic screen. The output grapher is important to dynamic simulation as it extracts what is needed to be applied to each joint during operation. Notice as it goes through the steps, the bucket lifts and the cylinder extends. The output grapher is showing the amount of time at about 200 steps. The red curve represents the unknown force, and the slightly angled blue line represents the cylindrical position. Selecting on step 200, we'll right-click it and then select Search Max. Notice that the bucket has dropped. Next, we'll right-click the step that was highlighted from our Search Max result and click Curve Properties to see the maximum. This maximum matches what was also displayed in the output grapher. We can close the output grapher and then exit the animation by selecting the Construction Mode button in the simulation player. Make sure you save all of your work before moving on to the next video in this project.